Hi, this is Kevin Trainer. Welcome to my lecture on Chapter 2 of the ID4e book. And Chapter 2 is entitled Understanding and Conceptualizing Interaction Design. So, just to sort of recap where we've been, human-computer interaction has moved beyond simply designing interfaces for desktop computers. It certainly includes that, okay, but digitally based interfaces are much more pervasive than that in our everyday life. So it's about extending and supporting all manner of human activities in all manner of places. So the good news is, as an interaction designer, the number of things we can get involved with has just increased dramatically with no sign of slowing down. What we want to do is we want to facilitate user experiences through designing positive interactions. We want to make work effective, efficient, and safer. We want to improve and enhance learning and training. We want to provide enjoyable and exciting entertainment. We want to enhance communication and understanding. And we want to support new forms of creativity and expression. So, what's this chapter about? Well, this chapter is about conceptualizing, and it's really about not getting started in the pragmatic, practical design test too soon. Before we have our head around exactly what we're trying to do, what do we want to create? So the way we describe this is we want to understand the problem space. What do we want to create? What are our assumptions? Will it achieve what you hope it will? Okay? So, assumptions. Why are these important? Well, the team that's coming to this problem space is not going to be without preconceived notions, and that's okay as long as they all prove out in the real world. So what we want to make sure is we're not taking something for granted that needs further investigation. So what we're doing here is we're looking at some visuals of people driving a car and interacting with their voicemail or perhaps their email while driving. Okay, well, we could start by assuming that that's what people want to do, or we could assume that they want to watch a TV program while driving, or we could say to ourselves, okay, there's an assumption in that, and let's make sure that we go explore that before we just assume that it's true. Because we could easily get down a path in which we could spend a lot of time, a lot of money, on the basis of some assumptions that perhaps were not well made. We also want to make sure about any claims that we're kind of operating on. Okay, and a claim would be stating something to be true when it is still open to question. So, for instance, a claim might be a multimodal style of interaction for controlling a GPS, one that involves speaking while driving, is safe. Well, a lot of people would say, well, I'm thinking that it might be safer than having to look at say, a display and touch the display. So it does seem appealing, Okay, but we have to make sure that we have properly examined this claim, and we're comfortable in relying on that claim before we invest a lot of time and money in it. So what we need here is we need a framework for analyzing our problem space. And the framework that we are suggesting here, I think, is a very practical one. Let's begin with this. Are there problems with an existing product or user experience? If so, what are they? Why are we doing this? Are we doing this because people are feeling some pain around something? They have products or services that are not getting them all that they would like. Okay, let's see if we can articulate that and come to some common understanding of what that pain is. Why do we think there are problems? What's causing that pain? What things might be causing that pain? How do we think that any proposed design ideas that we might have already had for the problem space might overcome these problems? And if we're designing for a new user experience, how do we think our proposed design ideas support, exchange, or extend current ways of doing things? So, certainly at the beginning of a project, we always run the risk that we can be kind of thinking and talking forever. There was a time when people call this analysis paralysis. You get stuck in this sort of analysis kind of mode. The opposite of that is that we jump right into doing. Okay, and there are a lot of people telling us that jumping into doing is a good thing. It's a couple places in the book where we talk about agile development, agile interaction design. This idea that we want the methodology that we're following to be lightweight, and we want to discover solutions sort of experientially. And what we just want to say here is that there's a lot to be said for getting started, and there's a lot to be said for experience. But before you start that, let's do a little thinking and talking to get us all on a similar page, and make sure that we're not about to go out and spend a lot of time and energy and money creating things that will subsequently realize were not a good decision because we just didn't think enough about the problem space and our potential reaction to the realities of the problem space. Okay, so one of the activities that they describe in the book is let's talk about 3D TV. Okay, 3D TV I've always found interesting because they certainly sell 3D TVs. I have friends who have 3D TVs, but it's never really appealed to me. So I know that there are differences in this. What kind of assumptions and claims surround 3D TVs? Here's some assumptions, okay? People would not mind wearing glasses that are needed to see 3D TV in their living rooms. Now, according to our authors, that's probably a reasonable assumption. Now, for me, it's maybe not reasonable, and for you, well, you're going to have to think about that. The next one, people would not mind paying a lot more for a new 3D-enabled TV screen. Not reasonable, okay? So the authors think that that's a little too much of a conclusion to draw on. Perhaps we should do some research to see how much people would be willing to pay for a 3D enabled TV screen. And how could we do that? Well, we could do that through running focus groups and those kinds of things. We could get some idea about what the cost sensitivity was for TV screens in relation to 3D capability. This third assumption, people would really enjoy the enhanced clarity and color detail provided by 3D. And our authors think that, well, maybe that's a reasonable assumption. Okay. I guess I'd have to see it myself to tell them if it was reasonable. And the next one, people would be happy carrying around their own special glasses, reasonable only for a very select bunch of users. So what we're trying to do in talking about these assumptions is we're trying to, kind of unpack this stuff. We're going to say, okay, we're coming at this, but what assumptions are we operating on? And can we rely on all those? Or do we need to go and do some research in order to find out if those assumptions are actually true? And again, we might want to do that research before we spend a lot of time and money on further developing our product. So the benefits of conceptualizing before getting into design action, okay? Because we say one could just jump right into design action, or one could conceptualize and then go into design action. So we're recommending the former, and here are the benefits. One is orientation. It enables design teams to ask specific questions about how the model will be understood. It's open-minded. It prevents design teams from becoming narrowly focused early on. And there's this kind of risk that design teams have, that they're drinking their own Kool-Aid. They just get so excited about their own ideas, they lose touch with where other people's thinking and feeling is located. They think it's closer to them than it actually is. And common ground allows a design team to establish a set of commonly agreed to terms. So we're saying that there are benefits to conceptualizing before design action. From the problem space to the design space. So having a good understanding of the problem space can help inform the design space. So we can do better at the design if we've done a better job of conceptualizing the problem. What kind of interface, behavior, or functionality is going to be appropriate? But before deciding upon these, it's important to develop a conceptual model. So we think that there's incremental value in conceptualizing before design action. What we say we'd like you to come up with is a conceptual model. Now, conceptual model sounds good, and it has kind of vagaries. Both the word conceptual and the word model are pretty general terms, and of course when you put them together they kind of multiply the generality, but we're going to try to hone in on what we really mean. So according to Johnson and Henderson, a conceptual model is a high-level description of how a system is organized and operates. Also, according to Johnson and Henderson, a conceptual model enables designers to straighten out their thinking before they start laying out their widgets. So, conceptualizing before design action. So what are the components of a conceptual model? Well, there are a lot of potential components, and we're going to try to introduce you to as many of them as we can. The first are metaphors and analogies. that allows us to understand what a product is for and how to use it for an activity. Or concepts that people are exposed to through the product. Okay, so there'll be perhaps some task domain objects. They'll have attributes and operations. Okay, so we'll start to talking about the things that you can do in this environment that we want to create. You can do saving, you can revisit things, you can organize things. So we're trying to really construct a vocabulary of how things go on in this solution space. Okay? And it gives us an opportunity to talk about the relationships and the mappings between the metaphors, the analogies, and the concepts. So, what are some first steps in formulating a conceptual model? We're going to ask ourselves questions like these. What will the users be doing when carrying out their task? How will the system support these? What kind of interface metaphor, if any, will be appropriate? And what kinds of interaction modes and styles, and we're going to be talking about interaction modes in just a couple of minutes, are appropriate to use? Always keep in mind when making design decisions how the user will understand the underlying conceptual model. Okay, so what we really want to do is we really want to put together a conceptual model that's going to help the user understand how to use our product and get all the benefits that the product or service has to offer them. So there are many kinds of conceptual models, and there are many ways to classify them. We're going to describe them in terms of the core activities and objects. And we're going to also describe them in terms of the interface metaphors that they capitalize upon. So let's talk about the interface metaphors. Okay. These metaphors help us to conceptualize what we're doing. Phrases like surfing the web are pretty powerful, not because people have been surfers, but they kind of get this idea from the phrase surfing the web. There's a certain kind of going with the flow to surfing, right? You can't surf somewhere where the wave's not going. There's a certain amount of control. There's a certain amount of reaction. And so surfing for the web was very appealing to people. Perhaps there's a conceptual model that's instantiated at the interface. Very popular in our formal computer interaction with, say, desktops and laptop computers, is this idea that we have a desktop. It's the desktop metaphor. This thing's been popular for, well, 35 years at least, probably a little bit longer. Or it might come down to visualizing an operation. Maybe we're going to have an icon for a shopping cart to place items into that's going to help us visualize the part of the application that tracks what we have and haven't selected for purchase. Some of the metaphors that we're going to deal with have to do with material objects and their properties. And one that's very popular, we talked about the shopping cart, very popular user interface metaphor. Another one is the card. Okay? Why? Well, people have been using cards for a long time. Interestingly, before we got to these digital computer information management solutions. There were a very popular group of card-based. We would have physical cards put in physical tubs, and we would sort them and do all kinds of things to them. So cards that have been appealing as an information management aid for quite a while. And quite a few products have had success in giving the appearance and the physical behavior of paper-based cards to digitally based information management products. One of the activities that we would like you to do is to go look at some product or service that has got some kind of a metaphor, some kind of a metaphorical aspect to it, and do some thinking about it. Here, for instance, if we were talking about online shopping, well, we've got shopping carts. We proceed to checkout. That's like we might do in a physical store. One-click purchasing is an idea that Amazon came up with that a lot of people, according to Amazon, they have patented one-click purchasing, although I think others would disagree. Gift wrapping, cash till. The question often is, how much of the metaphor from the physical world do we want to bring to the electronic world? With the idea that, metaphors are powerful, so we can get a lot of payback from them. But they're also, as powerful as they are, they're restrictive. And so, for instance, if people can do things in a physical shopping brick and mortar environment, there are some things that we can do in an online shopping environment that just have no brick and mortar corollary. We can do things. We can, for instance, have it compare products by price. Have it they can do things that just would not be physically possible in a physical store. You could, for instance, say that you would like to see all the products in certain categories by price, by how many people have bought them recently, you could get to the point where you just couldn't have the same kind of capability in a physical store, no matter how willing or knowledgeable your salesperson was. So restricting your design to only metaphorical things from the physical world can be very limiting, because then perhaps you won't go explore capabilities that are not possible in the physical world counterpart. Interface metaphors are very powerful. The interface can be designed to be similar to a physical entity, but also have its own properties. We've talked about the desktop metaphor. A number of us have worked with, say, web portals that, again, they're they mirror things in the physical world. They can be based on an activity or some object or a combination of both. They can exploit the user's familiar knowledge, helping them understand the unfamiliar. So the better your metaphor is, the more power you can get from it. It conjures up the essence of an unfamiliar activity, enabling the users to leverage this to understand more aspects of the unfamiliar functionality. Again, though, you have to remember that metaphors are a two-sided sword, right? So the closer and closer that you get to some metaphorical physical activity, um, if you want to keep the metaphor up and you want to have um, uh, you want to be slavishly dedicated to the metaphor, there will be some behaviors in the digital product that you won't introduce because they don't have a counterpart in the metaphorical physical world. So metaphors are powerful and potentially limiting as well. What are some of the benefits of these interface metaphors? Well, they make learning new systems easier because we're taking knowledge that we have about something we know and using it to understand something that we don't know yet. Um, it helps the users understand the underlying conceptual model. It can be very innovative and enable the realm of computers and their applications to be made more accessible to a greater diversity of users. So this, again, if the more we are taking people on a tour of things that they're not experienced with, if we can make use of a user interface metaphor, we can achieve a lot with that. What are some of the problems with metaphors? Well, I talked originally about what if you've got capabilities that you don't have in the physical world. Sometimes you break. That causes you to break a conventional and cultural rules. Um, a good example of this that they talk about in the book is this idea: if we're going to have the metaphor of a desktop that's going to be like the top of your desk in your office, then typically it wouldn't have a recycle or trash bin on it. Typically, we put those on the floor and they're out of sight. You have to know where they are. They're hidden because they've got sort of the uglies that we're trying to dispose of. Well, it turns out that even though putting a trash can or a recycle bin on the desktop is breaks a cultural rule, people seem to get used to it on the computer desktop. So that turns out to be okay. Um, we can believe our metaphor so strongly that we conceptualize a problem space, and then it kind of hems us in. Okay. For instance, a lot of early telephone computer telephony products would use a metaphor in the user interface would make them look like a physical telephone. Well, that was great, but then it was limited. It was limited to reproducing the features of an analog telephone. Then you have the problem when you want to have new features, you're kind of constrained by your metaphor. Sometimes your metaphor could conflict with your design principles. Um, it might force the users to only understand your system in terms of the metaphor. And I'll get back to computer telephony. There are many things that are possible with digital telephony that are not possible with, you know, call it analog telephony. So that if in fact we're using a metaphor from a physical telephone, we may have all kinds of capabilities that are just untapped by that metaphor. Things like, say, conference calling, um, which are going to be are going to be hard to hard to fit into the physical metaphor. Designers can inadvertently use bad existing designs and transfer the bad parts over. So let's talk about something like conference calling, right? Well, if in fact we're going to say take the classic desk telephone of 1975 and put that on the user interface, and a lot of early software that you would use, say, for dialing your modem and that kind of stuff back in those early PC days. When you clicked on dialing, it would look like a physical telephone that would be on your desk. Well, then the problem is, then how do you make a conference call? Well, on the physical telephones of those days, you flashed the switch hook. Okay, so you didn't quite hang it up. You depressed it for a quick time, and you would do that. You would see people who were going down the wrong road of interaction design, having the users model what was a sort of a weird behavior to begin with in the physical world, that flashing the switch hook. It's definitely something that you don't want to carry through into the digital world, and yet you would see people having the users do things that were just you really had the tail wagging the dog. You take some of the weakest aspects of the design in the physical world, and you would carry them over into the digital world unnecessarily. So these metaphors are a double-edged sword, and we offer them with that warning. Let's talk about interaction types. Okay. Interaction types are a way of getting us thinking about what the user's experience will be like when they're interacting with our system. And we've identified 4 here: instructing, conversing, manipulating, and exploring. And we're not saying that these are exhaustive. We're not saying that they're mutually exclusive, but that we want to make sure that you get the idea of each part. So let's talk about instructing. You are issuing commands and selecting options. 2 types of interaction that were of this instructing sort are command line interactions, where you get a prompt and you type in a command, or menu-based interactions, where you go through a selection of options, and typically each of them has some kind of a command where you're instructing the device to take some action. Contrasted with that is the conversing interaction type. So you are interacting with the system as if having a conversation. And I've got a couple of things that come to my mind. In the early days of computing, we had conversing kinds of interactions when even though we were doing these things in text, the device or the application would display some text, and then they would free up the keyboard, and you would type in some text, and they would free up the keyboard, and you would type in some text. And there was a very famous program that I think was called Eliza, that was pretending to be your psychiatrist. And Eliza would ask you questions, and you would say things back to her. And for its day, it was pretty cool stuff. A conversing interaction type these days are these digital assistants like Apple's Siri, who you get their attention and you have a conversation back and forth. There's a really good discussion in the text about how conversing, it seems very human, and it seems very appealing, but it has a lot of overhead. You can imagine if you've ever had the situation that you get a call from your parent who needs help with their computer, and you're on the telephone and you're conversing with them and you're kind of saying, well, now you're going to do this, and then they ask you and then you tell them and then they ask you and then you tell them. It takes forever. Okay, so there's conversing is appealing on some kind of a level, really appealing when you're asking questions and you're looking for kind of general answers, but it has a pretty high overhead for certain other kinds of things that you'd like to do. Manipulating is yet another interaction type. We're interacting with objects in a virtual or physical space by manipulating them. And I think a good example of that would be the marble-based answering machine. Okay, either in a virtual space or a physical space, we could manipulate the marbles to manipulate the messages, and you can imagine either version. And there's a certain appeal to that. And all those can be contrasted with exploring, moving through a virtual environment or a physical space. So probably the first exploring interface that I experienced was an early computer game called Adventure, that would begin by telling you that you're in a series of caves with a bunch of twisty passages all alike. And you would tell to do things, which was a little bit like instructing, and then it would come back and it would describe where things were. So there's a bit of a conversation there too, and yet the predominant aspect of this is that you are exploring a virtual space. This was a series of caves which you had to come to understand through your interaction. So these are not mutually exclusive, okay? They're just different types of interaction, and they get us thinking about what a lot of the possibilities might be. I'm not going to talk about this instructing slide because I talked about that already. Although I will come back and talk about this example of the vending machine. So the text gives us examples of these two vending machines. The one on the left is for the one on the left allows us to get 12 different drinks simply by touching the button that has the image of the drink that we want. The one on the right allows us to get maybe 30 to 50 different snacks, but we don't get to directly touch it. We have to figure out what its address is, and we need to type it into the keyboard. The point here is that these are both instructional. One is a little more direct than the other. And of course, it's possible because there are fewer selections. And there's a good discussion of this in the text. The machine that I think is an interesting sort of hybrid of these, and you've probably experienced it in some of the fast food outlets, you'll go, so you'll pay for a drink, and it costs the same for any drink, and refills are free. So you go out to the machine, and instead of having um, physical spigots that give out the different kinds of drink, you have an interaction with the touch screen. And in a certain way, you kind of have a conversation. In a certain way, you explore. And it's an interesting alternative between these two. Okay, you don't have some kind of exhaustive inventory of all the things that you can get. You're not kind of faced with that. You kind of discover your way to the soft drink that you want. And for some people, that's appealing. I know in the early days of that, I didn't like it, but I've actually become pretty good at it now. Conversing, we've already talked about, so I'm not going to talk about that further. Um, but I will talk about the example that they have in the text, which is this automated sales agent at IKEA, and they're calling the sales agent Anna. And would you talk with Anna? And of course, I don't know about you, but I've been given a lot of opportunity to talk with in these chat-based interfaces. Some of whom have you talking to actual people on the other end, and some of which have you talking to um, some kind of a bot. And they are conversational, and they are good for certain things and not good for others. Let's just look at what we had to say here about the pros and cons. Pros, it allows users, especially novices and technophobes, to interact with the system in a way that's familiar. And then the con, misunderstandings can arise when the system does not know how to parse what the user says. Something that I think that Siri does well is to respond well to cursing. And I'll leave it up to you to decide how I discovered that. Manipulating. Let's see, we don't have a good example of manipulating interfaces. Um, okay, so it can involve actions using physical controllers like the Wii controller or air gestures like in Kinect to control the moments of an on-screen avatar. Tag physical objects, e.g. balls that are manipulated in the physical world, result in physical digital events, for example, animation. Um, these are very popular. What's kind of interesting is some of these manipulating things seemed seemed unusual when they were introduced, and now we hardly even think of them as manipulating. I would the one thing that I want to point out is on touch screens like smartphones, we have this kind of pinching that we use to make things to either zoom in or zoom out on things. And I remember first seeing this in the CSI shows. You'd have these guys with these displays, and they'd be kind of pinching to make things smaller, or pulling apart to make them big, and it was clearly a direct manipulation. And these kind of capabilities are very popular. Those ones that you do with the zooming and the pinching are very, very popular. There are some other gestures that can be used in systems, particularly ones where you're, say, gesturing over a device, that are certainly a lot harder to learn. Why are these direct manipulation interfaces so enjoyable? Novices can learn the basic functionality quickly. Experienced users can work extremely rapidly to carry out a wide range of tasks, even defining new functions. Intermittent users can retain operational concepts over time. So this kind of gets me back to a discussion we were having on chapter 1. Um, Not all of our users are the same. We have novices, we have intermediates, we have experts. And so we're seeing here that there are things about these direct manipulation interfaces that might appeal to novices and or intermediates as well. Um, um, Error messages are rarely needed. Users can immediately see if their actions are furthering their goals. If if they're not, they can do something else. Users uh, users experience less anxiety when things are going well. I think that some of this direct manipulation stuff is very anxiety provoking when things do not go well. Users have the potential to gain confidence and mastery and feel in control. So certainly the potential is there. Touching one of these things and having the animation showing it crash and burn is pretty disconcerting. So the downside of this is not being. I don't think it's being quite adequately represented here. Because we have the next slide, disadvantages. Um, some people take the metaphor of direct manipulation too literally. Not all tasks can be described as objects, and not all actions can be done directly. So there's some situations where this adds a lot, and others where it could be kind of not useful overhead. Some tasks are better achieved through delegating, for instance, something like spell checking. They can become screen space gobblers because these graphical representations of things, in order to make them sufficiently appealing visually, can use up a lot of real estate on the screen. Moving the mouse around the screen can be slower than pressing function keys to do the same actions. And here we get down to the fact that different users are going to want different things. And the point that I made a couple of times, which is one that Cooper is very fond of, which is that users' preferences shift over their relationship with your product. So they begin as novices. If your product has alternatives, then they're either going to go out of the novice mode quickly and become intermediates, or they're probably going to quit it. And then they're probably going to oscillate back and forth between being intermediates, occasionally getting up to being experts, and then not using it for a while and going back to being intermediates. So it's not even a question of having different capabilities for different individual users. You probably are going to have different capabilities for the same user at different points in their product familiarity life cycle. Exploring, we talked about what exploring is. We don't have a good example to show you there, but I talked about the adventure game. So which conceptual model is best? Direct manipulation is good for doing types of tasks, i.e. designing, drawing, flying, etc. Issuing instructions is good for repetitive tasks, spell checking, file management. Having a conversation is good for children in the computer phobic. Um, Hybrid conceptual models are often employed where different ways of carrying out the same actions is supported at the interface, but that can take longer to learn. Um, so, in terms of the elements of our conceptual model, we're going to be interested in both the interaction type and the interface type. So the interaction type, what the user is doing when interacting with the system, i.e., instructing, talking, browsing, exploring. Interface type, the kind of interface used to support the mode. Is it speech? Is it menu-based? Is it gesture-based? There are many kinds of interface types, including, we talked about command, we talked a bit about speech, a data entry, form fill-in, query, graphical, web, pen, augmented reality, gesture. And again, these are not mutually exclusive. I mean, there's ways to combine these things that we see on this list in kind of interesting ways. Certainly, for instance, form fill-in is typically part of a graphical user interface, which is typically delivered these days through a web browser. So those are three of the items on this page that have a pretty close interrelation to each other. So which interaction type to choose? Well, you need to determine the requirements and the user needs. I can't emphasize enough that very few of these things are per se good or bad. Okay? They're only good or bad in relationship to the requirements and the needs of the user and the circumstances that the user is expected to be in. We need to take budget and other constraints into account. We're going to have to consider the suitability of a technology for the activity being supported. And we're going to cover these in the course when we're we're going to cover these issues that we talked about are covered as we design our conceptual model. Other people's sentences can get away from you. This one did. Okay, let's talk about paradigms. We have a whole series of things that are talked about a lot, and we want to make sure that we're all kind of thinking the same stuff when the word gets used. So a paradigm is an inspiration for a conceptual model. It's the general approach adopted by a community for carrying out research, shared assumptions, concepts, values, and practices. So when we say carrying out research, I would also add and implementing systems. So paradigms that we've heard about: desktop, ubiquitous computing, computing in the wild. Examples of new paradigms: ubiquitous computing, pervasive computing, wearable computing, tangible bits, augmented reality, attentive environments, transparent computing, and many, many more. Another term that we bandy about a bit is vision or visions. So how might we characterize the vision? Well, it's a driving force that frames research and development. We probably should have said research and development on the last slide as well. It invites people to imagine what life will be like in 10 years, 15 years, 20 years. A couple of these that were influential. Apple in 1987 had a knowledge navigator that was part of their vision. And if you looked at Apple's technology in 2011, it had been predicted by this vision that they'd come up with in 1987. Another couple things are visions like smart cities or smart health. They provide concrete scenarios of how society can use the next generation of imagined technologies. And of course, as we in information science know, this also gives rise to a lot of questions concerning privacy and trust. So these visions are things that we set out before ourselves as a potential place where we want to go, and then we either find our way there or we find our way somewhere else that we think might be more appropriate. Theory. So theories are things that we talk about a lot. So theory is an explanation of a phenomenon. So, for instance, information processing theory that explains how the mind or some aspect of it is assumed to work. It can help identify factors. So, cognitive, social, and affective factors relevant to the design and evaluation of interactive products. So, we'll talk about theories, and we'll put them in the kind of context that we're talking about here. Models. Okay, so a model, our authors would like us to believe, is a simplification of a human-computer interaction phenomenon. So when we propose a model, it's intended to make it easier for designers to predict and evaluate alternative designs. They're typically extracted from a theory coming from a contributing discipline. Psychology, for instance, give us the keystroke model, which is talked about in some detail in the text. What about frameworks? Well, a framework is a set of interrelated concepts and or specific questions for what to look for. So we have quite a few frameworks that we talk about in interaction design. Norman's conceptual models, taken as a whole, are a framework. Benford's trajectories represent a framework. They provide advice on how to design. Steps, questions, concepts, challenges, principles, tactics, and dimensions. So here's a new framework for human-computer interaction, which came from Rogers in 2009. And it includes a frame of reference, methods, theories, and perspectives, and outputs. And we're talking about some things from the past, how things were done in the past, and how things are going to be done in the future. So, how would we summarize this chapter? Well, we took a survey through a lot of terms that get bandied about in interaction design, and tried to find our way so that when we're using these terms throughout the remainder of the course, we've got some idea about what we're talking about. we talked about developing a conceptual model, and that involves a good understanding of the problem space, specifying what it is we're doing, why and how it will support the users. A conceptual model is a high-level description of a product in terms of what users can do with it and the concepts that they need to understand how to interact with it. And most importantly, we said, hey, don't go off and start doing design stuff before you have a handle on your conceptual model, because you might waste a lot of time and money. We talked about different interaction types. Conversing, instructing is providing a way of thinking about how best to support a user activities. And then we talked about a whole bunch of things that get talked about a lot that are similar ideas but different. Paradigms, visions, theories, models, and frameworks. So they provide different ways of framing information, design, research, and development. So, how's this all going to affect us? Well, hopefully when we're talking about this, we're using the same terms, okay? And we're getting better and better at using the terms as the weeks go on. Two, we have this idea that we just don't want to jump into designing. And no matter how much the people from Agile development have been telling us, well, don't spend a lot of time thinking, get to creating. We're going to make sure that we have a good conceptual model before we start creating so that we don't just thrash about. Those, I think, are the major takeaways of the chapter. And I'm going to say bye until next time. Bye-bye.